Okay, question 15, exercise 9F, I think. A line is drawn parallel to the axis of the parabola, x squared is 4ay. So let's just draw the parabola. That's x squared is 4ay. I'm going to put the directrix down here because we know that it talks about that at some stage. It's drawn parallel to the axis of the parabola. So the line's going, this is the axis. The line cuts the parabola at P, which is 2AP AP squared. Now, how do I draw this line, girls? So a line is drawn parallel to the axis of the parabola. Does this line go across or up and down? All right. So we know the line goes up and down through P. So it goes up and down, passes through the directrix at R. So that's point P. This is point R in there. All right. You should be able to give me the coordinates of R straight away. So here's my directrix, y is negative a. Give me the coordinates of R. 2AP across, negative a down. Done. First part. Then it says, show that the normal at P. Now, before you draw the normal at P, you need to draw something else. Always normals, you have to do tangent first. So I'm going to do the tangent at P in a dashed line. The normal at P would be this one. So it says show that the normal at P is parallel to RS. All right, I've drawn a really bad diagram. I'm going to stick S here. So here is RS. All right, not quite parallel. All right, I'm going to put this normal a bit higher. Can I have the tape? Oh, there it is. So my diagram's not very good. Shh. So girls, here's RS. You have to show that the normal at P, so I'm just doing that normal a bit higher. So show that the normal at P is parallel to RS, that's S there, where S is the focus. Now I've gone too high, but make them parallel. Okay, what do you want to call this? Whatever you like. Not T. Not Q. A will do. A will do. Okay. So girls, aren't they just asking you to show that RS is parallel to AP? All right. Actually, you don't even need the A. You just need to show parallel lines have the same gradient. Can you work out the gradient of RS at all? Do you know what R's coordinates are? So S has coordinates 0A. R has coordinates 2AP minus A. Give me the gradient of SR. How do you do it? Gradient. 2 points, gradient. Not gradient of tangent, gradient between 2 points. Gradient of SR. I want the gradient, girls, if you're trying to prove that SR is parallel to the normal at P, yeah. Y2 minus Y1 over X2 minus X1. Gradient of SR. Well, there's, I don't care which one, let's go, so we don't get all these. All right, let's go negative A minus A over 2AP minus 0. Isn't that minus what? Over 2AP, which is negative 1 on P. Oh, that looks familiar. Where do you recognise that? What's the gradient of the tangent always at P? And what's the gradient of the normal? So this is all we need to do is work out the gradient of the tangent. You're not allowed to just say gradient of tangent at P is P. You've got to differentiate. So at point P, we've got X equals 2AP, Y equals AP squared. Look, they actually did give you, sorry, back up here, the equation of the parabola. Do you just do that one? So at P, all right, girls, what I'm doing Girls, I'm trying to find the gradient of the normal. How do I find the gradient of the normal? I don't know what A is. Believe me, I don't know what it is. Girls, yes, you find the gradient of the tangent. How do you find the gradient of the tangent? Differentiate. Either differentiate the x is 2ap, y equals ap squared, or they told us that this is the equation. We're going to do it that other way. So what does y equal? Girls, when they give you the equation, use it. X squared is 4ay. What have we got? Y is, make y the subject, x squared on 4a. dy dx is, this is all gradient of tangent. 2x on 4a. Remember, 4a is just a constant, which is x on 2a. So therefore, the gradient of the tangent at P is, do you know what you do? What do you do? Sub what? Girls, this is the gradient function. Sub. All right. So at P, which is the point 2ap, ap squared, I want to work out the gradient of the tangent of P. So, yeah, sub x is 2ap, because that's my gradient function. Substitute the x value, and what do you get? Now, we know that already because you've done it a few times. You know the gradient of the tangent of P is P, so therefore the gradient of the normal at P is -1 on P. So therefore, the gradient of the normal at P equals the gradient of SR, which is equal to -1 on P. So therefore, parallel lines have the same gradient. Therefore, the normal at P is parallel to SR. Reason, parallel lines have the same gradient. So girls, see how this topic is all using information that you already know, using rules that you already know, but it's just using 2ap, ap squareds instead of numbers. Okay? It's using the parameters of the equation rather than the coordinates of the point. All right? Well, we have. No, show that the normal at P is parallel to SR, where S is the focus. We've done it. Therefore, normal at P is parallel to SR. Because we just found that they had the same gradient. We did the gradient of SR up here is -1 on P. The gradient of the normal at P is -1 on P. So we did the gradient. So this is the gradient of SR is -1 on P. We've just worked that out. Then we worked out the gradient of the normal at P is -1 on P. So these two have the same gradient. So if I go back up, do you want to see the original problem now? Gradient of SR is -1 on P. Gradient of normal at P is -1 on P. They're parallel. All right, people are looking very tired. You would definitely get a diagram for something like this. So, P and Q are points on the parabola, x equals 2at, y equals at squared, where P and Q have parameters P and Q respectively. So we've got 2ap, ap squared, 2aq, aq squared. It says find the midpoint of chord PQ. So please do not put it on the axis because it will make you start substituting x is 0 when it's not. So M is the midpoint. T is the point on the parabola where the tangent is parallel to PQ. Anyone want to come and show me where it is? Parallel to PQ. T is the point. No, the point T on the parabola is where the tangent is parallel to PQ. It's just a tangent, and my thing's a bit warped. So here's your thing. T is just on the parabola, and it's parallel, so it could be there. There's T. Got it? Yeah. T is the point on the parabola where the tangent is parallel to PQ. So we've got parallel lines here. Okay. Got any ideas what you might do? Can you find the gradient? Parallel lines have the same gradient. What could you find the gradient of? Quite easily. Yep, using no differentiation, P and Q are 2 points. Yep, gradient formula. Whatever gradient you get for PQ, it's the same as the gradient at T. All right? And then it says, and I is the point where the tangents at P and Q intersect. So this is a horrible question. Tangent to P and Q intersect at I. I's down there. Got it? So you've got all these points, M, P, Q, T, and I. I is the point where the tangents at P and Q intersect. I'd treat this as 3 separate questions. All right, work one bit at a time. The midpoint of PQ. Know how to do that? Midpoint formula. Hello? Right, midpoint. Girls, listen. Don't look at it and say, oh my God. Just look at it and say midpoint. I know how to do midpoint. Add the X values together, divide by 2. Add the Y values together, divide by 2. You don't sit there and freak out, all right? So, find the midpoint of chord PQ. Stop. Then we'll deal with the rest. Right, go. Add the X. What do? Midpoint. X1 plus X2 over 2. Y1 plus Y2 over 2. Right, what have you got? I like to add the P before the Q, please. 2AP plus 2AQ on 2. Y values together. All right, we can do some, you could factorize out the 2A. We're just going to make it look a bit and put it over 2. Factorize, because you're going to have to do something with it later. A bracket P squared plus Q squared cannot be simplified unless you're doing extension 2. And out next bit, the tangent at P we know is parallel to PQ. Whenever there's reference to lines being parallel or perpendicular, it's got to do with gradient. Parallel lines have the same gradient, so the gradient of PQ is gradient formula. Yep. Gradient of PQ is Y2 minus Y1 over X2 minus X1, which is AP squared minus AQ squared over 2AP minus 2AQ. So, do you know what you've got to do here? Factorize. A. Let me factorize the bottom first. T, 2AP minus Q. Instead of writing A bracket P squared minus Q squared, do you want to factorize the whole thing straight away? What do you got? Well, it is A bracket P squared minus Q squared, which is P minus Q, P plus Q. See, once you practice this over and over again, see, we've seen this before now. This is probably the 3rd time we've done it. So cancelling the P minus Qs and the A's, we get P plus Q on 2. Now, that's the gradient of PQ. So we can say, therefore, the gradient of the tangent at T is P plus Q on 2. Yeah. Well, I've got tangent at T is parallel to tangent to PQ. We know that the gradient of the tangent at T is P plus Q on 2, but I can't do anything with that because I have to find the coordinates of T. Now, I know that T is the point 2AT AT squared, so I've got to work out what T is, all right? Now, what I know, because I'm trying to work with gradient of tangent at T, I'm going to work out the gradient of tangent at T using differentiation the way you normally would have, okay? So, if T is the point 2AT AT squared, girls, this is quite a little bit complicated, all right? Or the thoughts are a bit. You've got X is 2AT, so dx dt is what? 2A. dy dt is? Yeah, it's A times 2t, which is 2AT. So dy dx is, isn't it dy dt times dt dx? I'm differentiating at point T. dy dt is 2AT, dt dx is 1 on 2A. Girls, you know how you know gradient of tangent is, we've always been getting P? Well, we're getting T now because we're talking about point T. Gradient of tangent at Q, you would get Q. So now that's what t equals. So if the gradient of the tangent at t is that, and the gradient of the tangent at t is that, do you get that? This is the gradient of the tangent at t. It's this. So I've got gradient of tangent at t is that, gradient of tangent at t is that. Therefore, little t equals p plus q on 2. It's tricky. I've worked out the gradient of the tangent in 2 ways. Normal method using differentiation and using the fact that it was parallel to PQ. That was that. So because I've worked out gradient of tangent at t in 2 ways, then the 2 answers have to equal each other. So now, therefore, the coordinates of t, which are 2at, at squared, I'm just substituting the little t with the p plus q on 2. Well, t has coordinates 2at, at squared. I've just worked out that t is p plus q on 2. So therefore, t is 2a bracket p plus q on 2, comma, a p plus q on 2 all squared. So, girls, I even had to think about this one. So, and I've done this many times. I've got that t has coordinates a bracket p plus q, and looks like we can't do much with the other one. A bracket, let me just turn that off. 2 all squared. You know how you've got to square the top and the bottom? Over 2 squared, which is 4. Girls, I'm not expanding. I don't want to expand that thing. I don't want to get a... I'm just keeping it as p plus q all squared over 2 squared, which is 4. So they're the coordinates of t. All right, I've got a few more minutes before I get the girls. Let me just work out I. It's where the tangents at p and t intersect. Then you've got to find the equations of the tangents and do the point of intersection. So see this question